let's now go on to determining the equation of this. Let's now go on to determining the equation. So what happens if the opposite is given? Now they give you the graph and they tell you to find the equation of the graph. Right? They give you the graph. So here goes. There's the graph. They tell you that is 2. They tell you that is -1. And they give you a point here, P, 4 and 3. They call this is now your question in the exam. So now they don't ask you to sketch. Now they don't ask you to sketch. They now ask you to determine the equation of the graph. So in our answer, we need to ask ourselves what is given in the graph. Our two x-intercepts are given. Now, the question in the exam gave you this and it said that f of x, graph f, is given by this equation. So you need to find a, b, c or a, p, q. That's the same thing. What is the method? So I'm going to do the answer here. It's going to be quite a bit of calculation, so you need to stay focused. Now, the first question we ask ourselves in our mind, what is given? What's given? Two x-intercepts. Is the turning point given? Have a look. Is the turning point given or are the two x-intercepts given? Answer it for yourself. The answer is logic, right? It's obvious. There we go. Our two x-intercepts are given, right? Remember, that's your x-axis, that's your y-axis. So there we go. Our two x-intercepts. So whenever two x-intercepts are given, whenever two x, I'm going to write it here on the top, whenever two x-intercepts are given, and a point, let's just say that point wasn't given. Then you would just go y equals x minus x1 into x minus x2. Okay, meaning that you would just go and say, let's break that up. You would say x minus minus 1, x plus 1 into x minus 2. And all you would do now is you would multiply it out. Y is equal to x squared plus 1x minus 2x is minus x minus 2. And that would be your final answer. That's A, that's P, that's Q. That's A, that's B, that's C. But a point was given. So they gave you a point here. What was it? 3 and 4? There we go. Now, the formula changes slightly. The formula changes slightly. And let's go. Whenever two x-intercepts and a point. Now we're going to use y equals a into x minus x1 into x minus x2. There we go. Now, the point now will be substituted for x and y. What is the purpose? To solve for a. So whenever a point is given on a graph, you always need to find a. You're always looking for your a value. A value generally is never given. You're always looking for your a value. So let's substitute. So we've got y equals a into x minus x1 minus minus 1 plus 1 into x minus 2. Now we've got x and we've got y. We now plug it in for x and y. So there's your y value, there's your x value. Plug it in. We now need to solve for a. Remember, in an equation you need to solve for only one unknown. So what's your y value here? 4 is equal to a into what's x? 3 plus 1 into 3 minus 2. 4 is equal to a into 3 plus 1 is 4, 3 minus 2 is 1. In this case, it's purely coincidental, guys. It's absolutely purely coincidental that 4 equals 4a, a equals 1. In this case, like I'm saying, hear me out, it's purely coincidental. This could be a fraction. This could be anything, right? This could be this a value could be a fraction. It could be half, it could be a quarter, it could be minus 2. Doesn't make a difference. We now take this a value and we plug it back into there. So we say y is equal to, in this case, 1 into x plus 1 into x minus 2. In this case, it works out that 1 times anything will still stay the same. X squared minus x plus 1x minus 2x minus x minus 2. If that value changed, let's show you a situation in which that value changes. Okay, so let's change this value. Let's make that 4 and 6. So now what happens? So instead of this, so all that will come out now, right? In fact, let's redo it from here. We now start with y. 6 is equal to a into x, 4 plus 1 into 4 minus 2. So 6 is equal to a into 4 plus 1 is 5, 4 minus 2 is 2, 6 is equal to 10a A is equal to 6 over 10, which is equal to 2 goes into there 3 times, 2 goes into there 5 times. We got A is now 3 over 5. A is a fraction. I just did this here. I changed this value just to show you that that A value doesn't necessarily have to be 1. It was, like I said, purely coincidental in the previous example. So now take this 3 over 5 and plug it back into there, because we need our final equation. So y is equal to 3 over 5 into x plus 1 into x minus 2, without the coordinate, without the x and the y. Now multiply it out. Y is equal to 3 over 5 into, this will give me x squared minus x minus 2, multiply this out, and that will be your final answer. Y is equal to, or f of x is equal to 3 over 5 x squared minus 3 over 5x minus 6 over 5. So that's your A value, B value, C value, A value, P value, Q value. That's your final answer. AX squared plus BX plus C. Okay, so this was type 1 of the parabola, the one where it was a trinomial. We showed you how to sketch. And now when two x-intercepts were given, how to, remember, in mathematics everything is forward and reverse. You do products, which is the forward, you do factorization, which is the reverse. You do sketching the graph, which is the forward, and you do determining the equation, which is the reverse. So everything you need to know back to front, inside out, upside down.